Mr. Investor, welcome back to the channel, baby. Please remember, none of this is financial advice, it's for entertainment only. So I'm going to start creating some small videos, some sort of bite chunks videos. Today we're going to be looking at key opinion leaders in genomics, what they've been through, where they've come from, and what they think of optical genome mapping. Shout out to the Stock Twits Bingo Cowboys, Jan Mitchell, talking about the reason why he holds bionano genomics and why he continues buying. He said it's a long-term retirement play for him. What this gentleman posted was pretty tasty. He reposted a post from Brian Kruger, PhD. This guy is a scientific strategist, storyteller. Let's reduce costs and increase transparency in healthcare. So first, let's take a look at what he's currently working on. This guy is the Vice President of Lab and Research Development at Everly Health. Everly Health, better care for better health. We believe modern healthcare is achieved when everyone has access to modern, diagnostics-driven care. So these guys have created this kind of triangle here between consumer expertise, enterprise expertise, diagnostic expertise, put it all together, and you've created a new kind of healthcare experience that's centered around people-centered care, holistic care. So now they've got this infrastructure that guides the full testing experience with the support of a national clinician network composed of hundreds of physicians, nurses, genetic counselors, PharmDs, and member care specialists. He states they serve over 20 million lives annually. 250 plus enterprise clients. Oh yeah, what's cooking good looking? This guy's been talking about the next disruption in genomics and how it's not sequencing, but it's actually mapping. But before we get into that, why does this man's opinion matter? Let's take a look back at his experiences. He states that his areas of expertise lie in molecular genetics, molecular microbiology, qPCR, high throughput sequencing and genotyping, and then he states Sanger, Illumina, Infinium, PacBio. He also said he has experience with high throughput automation such as Hamilton. Scrolling back through the years, you will find that he was the director of genomic analysis and technical operations at Columbia University Medical Center. This was from 2014 to 2015. He used some high throughput sequences, including the high SEQ 2500 sequencers. And also during 2014 to 2015, for a year, he was a council member at Gerson Lerman Group. What they used to do was discuss sequencing and related technology trends in the genomics and biotechnology sectors with investors. A few years back from then as well, he was an associate director at Duke University. He ran genomic analysis facility at the Center for Human Genome Variation. These guys had 7 Illumina high SEQ 2000 sequencers. So basically this man has a chunky range of experience and he put out one of his opinions. And in this opinion, I'm going to read through to you now. He spoke about the next disruption in genomics and how it's not sequencing, but it's mapping. And he put a little quote there. He's like, Brian, you're an idiot. Although generally true, you should hear me out. One of the biggest areas in clinical genetic diagnostics is cytogenetics. And when I say clinical diagnostics, I mean the reimbursed kind, you know? The kind that actually gets paid for sometimes. While rapid baby sequencing is all the rage and a handful of states actually reimburse for that sort of testing, the majority of prenatal, postnatal, clinical genetic diagnostics that get paid for fall into the category of cytogenetics. A little summary of cytogenetics is a field within pathology that deals essentially with our cellular anatomy as it relates to chromosomes. Since, for the longest time, humanity's best guess at trying to figure out genetic disease was either to look at the physical attributes of a person, which is the phenotype, and or the chromosomal superstructures within cells. Doing anything interesting at scale with genetic sequencing in cytogenetics is a very recent advancement, and that probably explains why the archaic techniques used in clinical cytogenetic testing still exist. This is underscored by the fact that up until about 2005, metaphase karyotyping was still the gold standard cytogenetic technique. Now we've upgraded that to array comparative genome hybridization, but in the 21st century we can do better, faster, cheaper, with far higher resolution. The traditional methods for looking at chromosomes include FISH, fluorescent in situ hybridization, which is where fluorescent labeled probes are used to detect specific chromosomal abnormalities. Karyotyping, either stain-based banding or more recent molecular banding-based techniques with a resolution of about 5 megabases MB. ACGH, array comparative genomic hybridization, which is the use of array technologies to detect genomic anomalies. 50 to 100 kilobase resolution. But what about non-invasive prenatal testing? Isn't that sequencing? Yes, but it's not diagnostic, and the resolution of NIPT is on its best day 5 megabases. It also cannot reliably detect inversions or translocations because short reads. Okay, then what about whole genome? Let's sigh. Same problems as above, but with better resolution. If you're doing whole genome sequencing anyway, Adding cytogenetic analysis can be used to rule in a diagnosis because short reads miss things. It can't be used to rule out a diagnosis. Enter high-resolution genome mapping. For the paltry sum for about $100, you can perform high-resolution genomic mapping using bionano Genomics' Sapphire system. Bionano uses 2 enzymes to fluorescently tag DNA. These little signposts can reconstruct a genome with a resolution of about 3 to 10 kilobases, picking up everything that short reads and ACGH miss for about half the cost of doing ACGH. And if you have a penchant for only doing things with sequencers, you can spend a bit more money to use high-C based techniques from ARIMA or phase genomics to make similar reconstructions. This guy had lots of reactions and quite a few comments. There's over 108 reactions, 23 comments in here. People were asking $100 per sample. How much off is this estimate? Brian Kruger replied, Bionano continue to focus on improving the throughput of OGM for even higher volume laboratories and aims to increase the throughput of a single system to as much as 17,000 samples per year by the first half of 2023, while reducing the consumables cost to the target price of $100 per sample. $100 is future looking. Right now, the price is actually $500 per genome. A lot of people that work in the field, a lot of scientists were saying very interesting. Drop in their comments and we can see the Vice President, Alex Hastie, was saying that anybody wants to talk about OGM, feel free to reach out, trying to make them sales, baby. So now you guys might be saying this is one professional, this is one opinion leader. There's also been several recently that have been talking about, bionano genomics potentially replacing karyotyping. So I made this video, it's a bit short. I wanted to break it down for you into bite-sized chunks. The next video is going to be on something similar, another opinion in the field from LinkedIn. If you like these kinds of videos, hit the like, hit the subscribe, drop me a thumbs up, drop me some comments down below as well. Please always remember as well, Bingo Cowboys, this is not financial advice, for entertainment only. I'm still holding 10k shares, but I'm waiting to see if the price is going to drop a little bit more. Maybe we're going to go for another rough patch. If it drops below $2, I'm going to continue accumulating again. And I'm actually waiting for a buyout from one of the other companies that I own. Occidental Petroleum. Warren Buffett said that he's going to buy up to 50% of the company. He might go for a total buyout of the company. I'm not sure. But if he does, then I'm going to have maybe some cash on board where I can just continue to load up on bionano genomics. Wishing you all the best. Mr. Invest a lot. Over and out, baby. See you in the next video.